All right, welcome back. And here we are. We are in the middle of a series of videos on YouTube, well, or wherever you're watching this, documenting our attempts to build our own custom programming language using, we're writing it in C++ and using tools such as Flex, Bison, unit tests with Google Test, and doing Doxygen for our documentation generation. Just basically the entire setup of building a large project. And we are in video number 13 at the moment. And this video is all about, well, we're finally to the point where we can parse an integer and we can parse a float. And now we're going to do what we will call our first binary operation, and that is addition. Now, binary, you probably have mostly heard about that term in computing, meaning ones and zeros. And yes, that binary meaning two digits, or two possible digits, one or a zero. Yes, that is one meaning of the word binary, but another meaning is simply meaning something that has two parts. And when you have a value of 1 plus 2, the plus has something on the left-hand side, something on the right-hand side. It has two operands. And if the plus is the operator, then it has two operands, things that it acts upon, a left-hand side and a right-hand side. And so our goal today is to support that. And if we have time, we'll look at how do we then support an error message of some sort. But for right now, we're going to jump in and work on adding our operand, or our first binary operator, the plus. Okay, here we are. Oh, I'm not in the right directory. There shouldn't be anything. Yes, we are clean. And if you're dying to know, the very last commit was making the updating the documents for episode 12. So we are ready to go. And we're going to edit. Let's see. Remember, anytime we add something to our library, we have to change, we have to touch our project in multiple locations, right? We've got to, I can go ahead and say make watch test. Okay. We've got to add tokens to Bison. We've got to add patterns to our Lexer Flex, right? And then we've got to add AST types for how do we compile this? How do we execute it by the program? And then lastly, what is a computed expression that it returns? And so we've got all those different parts. So first, let's just jump into Bison, and we'll start there. And we are now. First of all, I just want to make sure I'm putting this in the correct place. Let's take just a moment. So this is indeed a token, but it's not going to have a type associated with it, and that's fine. So we don't have anything in angled brackets here. And I want to also adjusting my windows on my other monitor so that I can make sure I've got the right thing showing on screen. We don't need any angled brackets, but we do need a name, and we're just going to say, plus. And we'll give it a kind of user-friendly name of, the plus sign. And now we need to go down to yeah, we can do it this way. Our expressions here. And so far we've got an integer and a float. But I'm going to make the integer an or just because well, no, I'm okay with that being first. And we'll just add after it. We'll add something after. And it's going to be, not all caps, expression plus expression. Okay. And so again, this is in the terminology of a grammar. And grammars are just pattern substitutions. So it's the idea of Bison will do the work of figuring out an expression could be an integer or it could be a float. But it could also be something plus something, right? And so this could be, because it's an expression, it could be an integer. So we could have an integer plus a float. We could also have something plus something plus something, right? That would form a tree-like structure. And we're probably going to have to tell Bison which way we want it to work, but we will burn that bridge when we get to it. Fun phrase that is entirely wrong. And what we're going to do, we're going to say our double $sign. That's what we're returning up. And this has got to be a pointer to an AST node. And we're going to say it's a new Tang AST node. And I'm going to say add instead of addition. And what are we going to pass it? We're going to pass it $1, $3, because the 2 is the what am I trying to say? Is the plus sign. And then you know what? The location is actually the 2. Yeah, that should work. Is there anything else? For that, probably not. Let's see. Oh, invalid character plus. Of course. We could say plus. And in fact, I bet if we do this, it will... Oh, it doesn't know what AST node add is. Okay, fine. What this is true. We could have said plus because we defined it as plus, where that's going to be up here. That's the name of our token, plus. However, that's not very reading friendly. So instead, I'm going to replace it with the user-friendly description, and Bison understands that just fine. Okay, still not going to like everything, but and in fact, notice it says, hey, there's a shift-reduce conflict. Shift-reduce conflicts get confusing rather quickly. It's just saying it doesn't know what to do with, because it could have something plus something plus something, and which is, let me just write it out here, because the somethings and somethings and somethings are kind of hard to understand. If I have 1 plus 2 plus 3, am I meaning 1 plus 2 plus 3, or am I meaning 1 plus, and then in parentheses, 2 plus 3? Which grouping do I want? The first grouping or the second grouping? And that's what Bison is saying I don't know which one you want. And we can specify precedence rules in order to make that go away. And I believe I can do that. Yes. Precedence rules. And we'll just do the first. We'll say it's right associative and it is right, isn't it? No, sorry, it is left. I am wrong. Left associative. And notice it got rid of our Bison error. If I scroll up, you'll see that before it said, hey, I don't know what to do there. In fact, I was going to say we could run the Bison command, which we can see here, that our makefile spit out for us. But we could run that and give it a -w counterexamples, and it will generate examples of, hey, I don't know what to do in this case. And shifting or reducing is how it does a parse through as it's ingesting tokens. So anyway, all that's to say is by setting the associativity, that got rid of the first error. All right. Now the next error is, hey, I don't know what AST node add is. That's because we haven't defined it yet. But I don't want to do that yet. I want to edit our lexer and there we go. We're down here to our patterns, and again, I'm double checking my notes. Yep, that's what it is. Okay, so what do we have here? We've got our initial script. Sorry. We've got this minus and an integer, the minus optional here, and a floating point number. We're going to add a new one, and the plus has a special meaning in regular expressions. It means whatever the previous character was one or more times. So if it's an A plus, that means it would match a single A or 2 A's or 3 A's or 15 A's. Okay, but it just means whatever. So what I was saying is if there's an A plus there. But I don't want the plus to operate as that magical command thing of saying, hey, one or more times. Rather, I want it to be the literal character. So we do the \plus. And now when we see that, what do? Well, we just return Tang parser, and we just define this, make a plus, and we don't need to pass anything else to it because we didn't put anything in the angle brackets. And we always add the location. There we go. And I don't think Flex gave me any errors. Yep, we're good there. Now we need to add this AST node. So edit our includes AST, and we've AST node. Let's see. We got an AST node float. Let's just copy this as a base. All right. And now we need that represents all right. And what did I call this? I called this add, right? Add. And now we're not going to have a parameter that is the number. Rather, we're going to have a parameter that is first the left-hand side. And RHS will be the right-hand side expression. Okay, and we no longer need this. Rather, it's going to be the left-hand side expression. And this is going to be LHS, and then the right-hand side expression, which is so we've got LHS, RHS. This is going to be AST node star LHS, AST node star RHS, and we're going to call the default constructor, and now the LHS RHS is going to be RHS. There we go. Simple enough so far. And it's still not going to like everything. It's saying we're missing some stuff in our vtable for AST node add. That's fine. We need to supply something, a dump and a compile and a make copy. That's right. So AST node add. This is in our source/AST. AST node add. And okay, so this is the first one. The dump is going to be a little interesting. We're going to say add and we have now a left-hand side and a right-hand side. So, no, I could have left it that way. Return that plus this arrow. Well, no, I want to actually say what it is. Indent plus LHS, left-hand side. Plus, and it's going to be this arrow, left-hand side, dump, and we're going to make it indent by that plus 4. And now we're going to do the same thing with the right-hand side, except this is going to be right-hand side, right-hand side. Still not going to like it because I haven't finished doing everything. Ooh, what about the compile? You know, we can do that. This should be add. And so we're going to have to add our opcode, but I'm going to make this very naive at the moment. Later, I think it's going to be a little bit more sophisticated, but it's just it's an opcode add, and well, sort of. So first, we're going to say this LHS compile program. Now the goal is whatever's on the left-hand side, say it's a 3, that we say, you know what, do your thing, compile, and it should give the opcode to put an integer 3 on the stack. Now we're going to do the exact same thing with the right-hand side and tell it to compile its thing, its expression, and say it's a 5. And it'll put that on the stack. And then we add our opcode, which is going to be just add. All right. The end result, or the way our add will work, is it will pop off the right-hand side because it's a stack. So the left-hand side got pushed first, and then the right-hand side will be pushed on top of it. So when we pop off the right-hand side, pop off the left-hand side, and now we're going to add those together and put the result back on the stack. That's how we want it to work. So in these 3 lines, we have all of that behavior. It doesn't matter how complex the left-hand side is. When it compiles and when we execute it, all that should be left on the stack is whatever that is. Yeah. Okay. What about make copy? We need... Oh, this is add. And we're going to... And that should be this arrow left-hand side, arrow make copy. So it's recursive. And RHS make copy. All right. And it's saying, yeah, it doesn't know what add is. No, we haven't built it yet. We haven't put that in. So let's do that now. We're going to edit the includes, and is this opcode? Yeah. We called it add. So add. Pop the right hand side, pop left hand side, and then push LHS plus RHS. Okay, that's what it means. Everything should compile at this point, but we haven't written it. And of course, we don't want what happened yesterday or the last video. It was yesterday, but we don't want that to happen where it we forget to write in the program what to do when dumping or compiling. So let's do that. Let's program. No, that should be in the source program.cpp. And I'm strongly thinking about moving the dump bytecode into a separate file and the execute into a separate file, just so that they're not as unwieldy, because they're just going to be one, trust me, really big method. So I'll think about that. All right, so we've got here case opcode add. And, ooh, we need a new check here. Why? Because, well, when we get to an opcode add, we don't need to do the program check. We don't need to see if there's more instructions, because it's a 1 byte thing. In fact, I can go ahead and say plus plus PC and then break. We know that that is coming, but we need to check that our stack has 2 things. So you know, let's just call it stack check, and we will let it be, well, in this case it needs to be 2. We haven't written stack check yet, but we will. And assuming we're now at this point, that means we got past the stack check. And so we need to say auto well, it's garbage collected, but what do we say? The right hand side gets popped first is equal to do we have a stack? Have we created the stack yet? No, we have not. So, well, you know, it's just going to be called stack. So let's go ahead and write this. So stack dot back. So whatever value's at the back, and then we have to do stack dot pop back. And there's a paper or something written about this, that it's impossible to get the value at the back and pop in the same excuse me, in the same operation and it be atomic or something like that. There's a problem with it. So in C++, it is 2 steps. You get the value and then you pop it. And we can do the same thing with the left-hand side. Stack.back. Stack.pop back. And then lastly, we're going to do a stack.push, push back probably. And what? And the answer is we need to do RHS plus LHS. And we haven't written how that works yet. But we will, don't worry. Let's first get our stack check macro. So this is going to verify the size of the stack vector, and it's going to be a vector, so that it may be safely accessed. And the parameter is, I'll just say X. The entries now, why am I doing it this way? Well, 1 moment, I'll tell you. Dot size is less than, and we've got this thing called FP that I know we're going to need, but you don't know how it's used yet. It's the frame pointer. And that is, later when we deal with recursion and everything, we'll need a frame pointer that says, oh, you're in a, you're executing a function and it's this far into the frame. That way, everything that we write is just referenced from the frame pointer. So if the frame pointer's on 100 in, and I say, hey, and I need to make sure there's 2 things on the stack, then it's the frame pointer plus those 2 things. I need to make sure that there's 102 things on the stack. All right, so if it's less than that, however, what do we want to do? We want to return. Oh, no. I don't want to return something. We're going to make a to-do. Push an error onto the stack. We don't have the idea of an error yet. We'll get there. And we will just say that the PC, the program counter, is equal to the bytecode size, which is how we exited earlier. And then a break. Why do I not have... There. Okay. Now it's a proper if statement. That's the first thing. And now, going to test these. I was holding it back until I could hit the mute button. Note to self, make a mute button a hotkey so that I can sneeze in peace. All right, so we need to make a stack for the execution. Here's that frame pointer that we had created a long time ago saying, hey, yeah, we're going to need that. And hey, there's our vector of garbage collected. So the stack does exist. Was I putting that in the... I was. This is in the wrong place. Let me copy and paste that down here. There we go. All right. This is where the stack check should happen because here we have the FP and the stack. And here we have, the stack being referenced. The stack check is 2, but of course we know it's going to expand to a macro, or it's a macro that expands to add that to FP, whatever that is. And should work. I want to go back to that. If the stack.size is less than, and I just want to make sure, when we first start this, we know that FP is going to be 0, X is 2. So we say if the size is less than 2. But if there's 2 things on the stack, the size is 2. So it should be, that would be okay. So it won't go into this. So but if it's, yeah. Okay, this is right. We're good. And now we need to clean up where I messed up here. I put it in the, this is our dump bytecode. And we don't need any of this. We don't have to, there we go. All that we need now is add. Yeah, that's simple enough. And now it's not liking something. Oh yes, because I did this plus right-hand side plus left-hand side. And for this now, we have to do something to our garbage collection thing. And I think at this point, do we have, you know what? I'll look it up. Our include, that is not what it needed to be. Our include garbage collected.hpp. And look, we've got, well, this is templated. It must, does the entire thing need to be in the make file or only the part that's templated? Yeah, I don't think the rest of it has to be. Okay, so, you know what? We're about to find out. What I'm going to do is I'm going to make just garbage collected operator plus and this will have a const garbage collected ampersand, and that will be the left hand side. Okay, that's the goal. And it's going to say, no, I don't know, undefined reference. That's what I expected. Okay, now, I don't think that we have a source slash, no, we don't. We're going to try to put it in that. So this is the garbage collected operator plus. Nope. Well, what does it take? It takes a and we're just going to say return. I'm just trying to get this to compile, and so this is going to be horrible. And now we need to edit our make file because we need to have this garbage collected.hpp in there. So it's going to be a new object. Okay. And now for this object, you know what? I'm looking at this. The AST.cpp, and I don't have in there that it relies on AST.h. Same way for computed expression. Should also include okay. program.hpp, that includes that. Tang base, I have that one. Tang parser. I don't remember the... I'll leave those two alone since those are auto-generated. But okay, garbage collected, compiling, not error, but garbage collected.o. Okay. Computed expression. I kept saying .h, and we meant to say HPP. Yeah. It doesn't like that. Okay, so what is that? 8. Hey, okay, we've got it compiling. We don't actually have it adding, but it should return a 42. So if we edit our test, not of a garbage collected, this is our normal test, and this is going to be test expression add, and what do we want for this to be? We'll say auto compile script, and we want 3 plus 5. Spaces don't matter. We can prove that in a moment, but we want to expect EQ and let's just put a 3 in there. Oh, well, we expect it to be an 8, right? And we expect this to fail. Yes. It returned a 42. That's actually good news because that means it... where are we? The garbage collected.cpp. There we are. It did get here. And it just... it returned a 42. Now we need to make it actually do the addition. And how do we make it do the addition? That's a good thing. Well, we're going to do a couple things. First of all, we're going to say auto result is equal to this arrow ref arrow, and I'm going to call it dunder add. Inspired by Python. I don't even know if the capitalization is the same as Python. I'm not really worried. Normally I will do camel case, but not the first letter unless it's an object. So add, and what am I going to add to it? The RHS, of course. And now it's no longer maybe unused. Now, why am I doing this in 2 lines? Because I know that we're going to have to do a little bit of magic in a little bit. We don't have errors yet. We don't have an error type. But the idea is that ultimately this will, return an error of some sort. And if it doesn't support it, and I'm just leaving room for that. I know it's coming. And yeah, we're doing pretty good on time. So that we'll call the ref add. That means we're going after, this is a computed expression. Dunder add is the method that we're looking for. It doesn't exist yet, so it's going to give us an error. Say computed expression doesn't have that. And we're going to say, I know that, but we're about to add it. We don't have computed expression open yet. So we need to edit the include for computed expression. We've got our is equal and now we're going to perform an addition. Maybe no. There we go. And RHS. Okay. Definitely a virtual. And what did I say? It's going to return a garbage collected. And the name is dunder add const I'm thinking if all these consts are going to get us in trouble at some point. We'll go with it for now. RHS. And we are const as well. And we're going to create this for the integer and the float. Still not going to like it because, garbage collected did something of type. Evidently we need to pound include it. Let's see. Now, what is it not liking? So this is going to be an issue where, at least I'm pretty sure, I'm eyeballing it, but usually it's because we have header files that include header files, and there's going to be a circular reference at some point. And we've got to say, usually we can get by with it by saying namespace Tang class computed expression, just as a forward declaration. Doesn't mean it always works, but you know what? That's a lot fewer errors than there were before. So we can go with that. Now, invalid use of incomplete type. So it doesn't know what all is in this yet. Well, not this, but so it's saying, hey, I know what a computed expression is because you told me, but yeah, but now it's trying to compile it, and it doesn't know how yet. So what's the best way to solve this? Well, garbage collected.hpp is where B7 and B8. Okay. So I'm moving it into here. And now $150. Same thing here. Doesn't know what to do. But that's all right because we can do the exact same thing here. CPP 7. And what did I do? Let's see. So that's a friend, so it needs to be, ref needs to be protected. Garbage collected does not name a type in computed expression. And this, we probably have the same thing. Garbage collected.cpp, line 7. I thought that I just... Oops. Well, I mean, this won't affect the fact that it doesn't like that line. So what I'm thinking is, I was like, well, surely if I declare that function as a friend, which I have, then it should be able to reach inside to the protected values. You know what? I think... Oh, we don't have the ads. Yes. Okay. I think we're back on track. And that is, we've created the dunder ad. for all of these. And now we need so computed expression. Now we need a garbage collected, and this is computed expression dunder add. What's it going to take? It's going to take a const garbage collected ampersand RHS const, and now we're going to do something with it. And that is well, the default, we need to return an error of some sort. But for now, we're just going to return a 0. Computed expression, what is this? Sure. Oh, and of course. And it's still saying, okay, it needs the float. And stuff like that. So okay, now we get to actually do something. Well, almost. So I'm just going to get all of this out of the way. Okay, so it's still not liking something. Right now, I have dummies in there for the addition. And let's see. Undefined reference to operator less than. For that doesn't make sense. because here we have it. I mean, I had the word friend there, but that's not going to work. Yeah. Okay. Okay, so it doesn't like it. I'm not going to spin forever on this. There is another way. There's a quick thing here about how to teach it to print. And where is it? How to print your values. And so it says if you can't in the needs to be in the same namespace. Oh, is it just because I don't have it in the right namespace? B8. It won't do that, but oh, I bet this is the exact same issue. Both of those have to be in the same namespace. Evidently, I'm wrong. Because it's an auto. Okay, so the problem is right here. The fact that this is an auto, but at the time of compilation, it doesn't know what types of things need to be populated. I wish there were a way I could give it hints. See, because it's looking for it with a looks like a double and an int, of course. You know what? I may just define them. An int and a double. And I'll probably need to do it with a true and a false and stuff like that. But watch it work now. Nope, almost. Oh, why? Oh. Yay! Oh, it took all that time to get us to the point of it compiling and showing us an error, right? So what's the error? We're kind of lost by this point. Okay, and I'm just double checking my time. I might speed through, uh, fast forward through some of those changes. Yeah, I thought this would have been done 20 minutes ago because we were so close, and then I made a little bitty change. Anyway, all right. So our test is the addition. Right now we're not performing the addition, so that's what we need to add. And that's going to be in our computed_expression.cpp. And so here we are. We're in the computed expression add. And what we're going to say is the right-hand side so if the type ID of RHS, is that going to be correct? Is equal to the type ID of computed expression integer If that's the case, then you know what? For right now, I just want to know if it's going to work. And the only thing is we're going to change that to a 1. I want to know if we make it in there. Yes, we are. Okay, so what this shows us, it says the result is 1. Before it was 0. That means when we do star RHS, we can tell, even though RHS is garbage collected, and the ref, which is being returned, even though that is a computed expression, it stores what type it is, and that's why we needed pointers in the first place. So to get at the polymorphism. So we can say if this is another integer, then I can tell it to do a, because I am a computed expression integer. How do I want to do this? Either way, we're going to make a computed expression integer, and what goes in here is what's going to be interesting. So we're going to say a no. RHS converted is a static cast to a computed expression integer of star RHS. Pardon me if I'm slightly skeptical, but that actually seems right. Show me the compile. Just trying to do a copy assignment. All right. Now I'm just trying to figure out the best way of doing this. You say, Corey, why are we spending so much time on this? Because, quite frankly, once we get this done, minus will be very easy. And so we'll multiply, and so we'll divide, and so we'll modulo. And so we'll less than, and so we'll greater than, and all of those. For those, we just have to add a Boolean type. But now we're just trying to figure out what's the best way of expressing these ideas in C++. So as I'm talking through this, I know I've got this maybe unused, and we're going to delete that because it's no longer maybe unused. I know it's going to compile again. So complain. So what are we trying to do? We're saying if it is a computed expression integer, that is fine. Then I want to think of it as a computed expression integer. It passed the test. That did it. I love it when it's just, I'm so close, and then all of a sudden, yeah, it just works. All right. Let's break more tests then. What number is test? That is number 10, and we're going to be going back and forth between 10 and 12. And all we're going to do is this should actually still pass. Oh no, because we're adding a float. So it should be working on the float side. Okay. No, I'll do it this way. So this is an integer, float, integer, float, integer, float. And it's failing 3 of them. That's fine. I can deal with that. So now if the right-hand side is a float, then now, it may not like that I'm trying to reach into the float and get its value. So you know, we'll keep that in the back of our mind. In fact, let's just try to compile now. Yep, it's private. So the question is, Yep. All right. So what I'm going to do is integer n nope. All right. Let's see. That should have gotten rid of one of the errors. And now we're down to 2 failures. That is good. And so the floats, it's going to be very similar here. But I want to do the float first. Okay. And that is if the right-hand side is a float, we cast it as a float, we make a float. There we go. If it's an integer, it's still going to be, oh, we're doing it as an integer, but we're returning a float. All right. And that means up here, wait, no, I said it right. So if we've got an integer plus an integer, we return an integer. An integer plus a float, we return a float. And here, a float plus a float is a float, and a float plus an integer is also a float. Yeah. All right, now because now we want this to be and by the way, this is let's do this makes me nervous. Why? Because some decimals cannot be accurately represented, and adding floats just gets dangerous. Did I need this one? Suppose not. and didn't change the numbers. P7. Oh. There we go. It's working. It's adding a negative. It is adding 3 numbers together. And you know what? You might be interested. Just for the moment. What if we do P9 dot I don't remember the method. Let's come back to this. Program. Program.h? No, but I've got program.cpp. Well, let's look at it. And test where we're coming back to is number 10. So dump bytecode. And do we have one for the okay, get code, get the AST. Is there a dump AST? Baby. Anyway, dump bytecode. That's what I wanted to do first. Not quit. P9. Or is it dump bytecode? I think it's dump bytecode. Tell me soon enough. Yeah, here's the bytecode for it. Push on a 3, push on a 3, add them. So it will pop those 2 off, and we have a 6 on the stack. And then push on a float, a 5.5, add them. Yeah, and it's 7, well, not bytes, 7 uint64Ts, but all right. And I think that's what it is. Dump. Is this one of those that I have to do? Yes, it is. And there we can see the structure of it. So there's an add, and where I'm looking at is right here. So an add, and the left-hand side is another add. And then once those are, and that's, so the first it pushes on this integer 3, then it pushes on this integer 3, then it does the add opcode, and then it pushes, and that's all the left hand side, and then it pushes on the float 5.5, and then it does this add. That's how it works. Happy about that? And there we go. Okay, so I'm just going to now make sure that everything's cleaned up, and we'll get this now back over here on the left hand side. Our status, all of that. Okay. Our message is that we, oh wait, before we commit, I always do make clean, make test, don't know why I did that. Anyway, okay, it all compiled. Let's get commit-m, add support for plus operator. Now, we will do our docs-pdf. Open in another window, but there we go. And amongst our classes, we now have our AST node add. That's good. What else? We've got our floats. I think our garbage collected stuff, that's all showing up just fine. Yeah, I think that was the main bulk of the work. And if that's the case, docs, anything. And what episode is this again? I always forget. Episode 13. Okay, so for episode 13, oops, I forgot that. And this is, let's see, it's Control O for write out, Control X. Okay, and git push origin master. And it is updated. Okay, so where does this put us? We now have a plus. That works. And it works between integers and floats. It returns the correct type. We can nest multiple ones together. That's always good. We can. So what's next? We don't want to add new types yet. I want to I just kind of stopped thinking there for a moment. I want to support errors. That is, if it's a type that it doesn't recognize, we should have an error. And our code should do something when it receives an error. So that is the goal for, I believe the next one is to to start including errors. So having said all of that, I do believe we're at a good stopping point. And again, as always, I hope you're having fun and thanks for joining in. Have a great day.